Thank you, Lynette, and welcome everyone to this month's Connect with BMC Helix ITSM and Remedy webinar. During our presentation today, you can ask questions of our panelists in the Q&A pod during the presentation, as well as at the end, we will be doing a live question and answer with our presenter. And the recording and Q&A from today's session will be posted within a week of today's live presentation. And at this time, for the Optimizing the Remedy Platform solution, I'll turn it over to Vipul Jain. Vipul?
Thank you, Greg. And thank you all for joining. Appreciate you all taking time out of your busy schedule to join this presentation. My name is Vipul Jain. I am Senior Director here at BMC. I lead the R&D performance team. I've been with BMC for close to 12 years now. Before BMC, I worked for Oracle in the performance and benchmarking space for 9 years. I'll be presenting Optimizing the Remedy Platform solutions today. So the presentation will cover 3 essential topics. Approach to coming up with an optimized architecture. We'll cover this topic in depth. We'll then talk about performance validation. A lot of time what I see is customers either skip this step or they don't give much importance. And what I want to say is that if you're doing that, then you are missing a crucial step. Then we'll come to monitoring and tuning. We will not be spending a lot of time on monitoring and optimization. I've kind of put here for the sake of completeness. There are dedicated technical presentations that are coming up. There's one on performance best practice for Remedy deployment. There's another one there's another one on JVM monitoring and tuning, and there's one on database performance. I highly recommend you attend or at least review those presentations. As most of you probably already know, performance management is an ongoing activity, starting with the right deployment architecture, applying the right configuration setting, and followed by monitoring the environment for any fine-tuning are key steps to fully leverage your system. Part of the reason why I'm presenting this today is, let's say if you miss a configuration setting, if you miss an index, if you don't have the right monitoring, those can be easily fixed. If you goof up on coming up with the right architecture, if your hardware is not properly sized, those can be expensive mistakes and they may take a lot more time to correct. So let's get started. When it comes to architecting a deployment, there is no one solution that fits customer requirements. Different customers have different requirements. Different customers have different expectations. There could be difference in the performance, throughput, high availability, security expectations. So the goal is to architect a deployment that is reliable, secure, flexible, performant, scalable, and that handles your current and future business needs. With that objective in mind, the first step is to clearly identify and document the business and system requirements. Evaluate various design options and choose a combination that fits the requirement. And then finally, we'll be also covering how to go about validating what you have architected. It is essential to understand the requirements from different angles. Each application component deployed may have its own requirements. For example, we recently worked with a large service provider where they had the requirement to create end-to-end tickets within X seconds. Within an application, there might be specific use cases critical to business. And then there are customizations and integrations to be looked at and handled properly. On the system front, performance and scalability is very critical. We hear from customers day in, day out. The users of the system expect certain performance regardless of whether he's the only one on the system or if there are additional 1,000 users on the system. There are other important factors as well. For example, bank typically deploys a firewall in front of their database servers. So there are specific security requirements that some customers may have. Also, high availability and disaster recovery are very critical nowadays. If you have a disaster recovery site, then it's also important to test the failover and failback capabilities. And not just test it one time, but have a process where you are testing it periodically. Finally, it is critical to translate this business and system requirements and document them in form of service level agreements. So these are quantifiable. And what I would also recommend is to qualify this as much as possible. So for example, you could just say 3 seconds of response time as expected from the system. Rather than just that, you may have something more concrete where you say 1 to 3 seconds for the users coming on LAN, and then under 5 seconds for anybody who is coming over 250 millisecond latency. So let's talk about some of the design considerations and decisions. So the very first one is central versus distributed deployment. We do have a few customers who have distributed deployment where the web tier is co-located close to remote user community, although there are very few. And as BMC, we actually recommend central configuration. Our applications have been optimized to be less chatty, and we do recommend central deployment. So for this presentation, we'll be focusing on the central deployment only. Virtualization. So today, I mean, it's a very common practice to virtualize your environment. You could use physical or you could use virtual, and both options are valid for Remedy. When virtualizing, I would provide a few tips. So one is consider one-to-one mapping between physical core and virtual CPU. What that means is no oversubscription, at least for your production environment. You can, for your development and QA, you can go and oversubscribe, meaning you can have more VMs and more virtual CPUs than actual physical hardware. For production, though, you want to make sure that you have enough capacity to support the workload that's coming in. Vertical versus horizontal. So let's say if you have a requirement of 16 cores and 32 gigs for your workload. Now, the very first option is deploying vertically, meaning just deploying single server with 16 cores and 32 gigs. For high availability, what we would typically do is add another server, so replicate the same configuration so that if one goes down, then you have the second server to take the same load. Let me also pause for a moment and define high availability, as different people have different concepts in their mind. So when I'm talking about high availability, what I mean is we should be able to cover a single point of failure without any impact on performance or scalability. So if my system is configured to handle 1,000 users and the response time is expected under 3 seconds, even if one of the server goes down, I should be able to serve the same 1,000 users and I should not see any degradation in the response time. So with this, with vertical scaling, you would end up with total of 32 cores, 64 gigs. Now, if you went horizontal, where you are deploying rather than one server, you are deploying 2 servers with 8 cores, 32 gigs. Please also note that we are not really dividing the memory because you still need almost the same amount of memory to hold the application data that you have in the system. There might be less sessions, but again, we generally go with the same memory. So with this configuration, now you have two servers, 8 core, 32 gig. You only need to add another server for high availability with 8 core, 32 gig configuration. So that if one goes down, then you still have two remaining to cover full load. With this, the total comes to 24 cores, 96 gig. Extending the same concept further, if I went more horizontal, meaning rather than two, now I have 4 servers, 4 cores, 32 gig each. In this case, again, I'll be adding one more for high availability with 4 cores, 32 gig. And in that case, I'll end up with a total of 20 cores, 160 gig. So as you see, as you scale horizontally, you are reducing the physical cores, but you need more memory to support the same number of users, the same application data on multiple servers. And essentially, there should be a good balance. So you're optimizing your resources while also taking into account all the other requirements you have. Hardware sizing. So here's the knowledge article that we have published. This knowledge article has a good starting point for the hardware sizing guidelines. We pretty much break the system into 3 parts, small, medium, and large, where small represents customers with 800 or less users, medium would represent customers with 2,000 or less users, and then for large, 5,000. Now, these sizing guidelines are a good starting point if you don't have any other data. If you have a system, then I would suggest you should look at your production system and then adjust according to your requirements, according to your future requirements. If you don't have any starting point, then this provides a good starting point. Again, the recommendation is use these starting points and then adjust based on the loop testing to make sure that it handles your specific workload, your specific requirements. We already talked about high availability and disaster recovery for a bit, so let me move forward. So we are now ready to dive into the deployment architecture design discussions. What I wanted to do is to make basically so that this whole discussion resonates, I've put together a case study. Now this is a hypothetical scenario. It's based on multiple case studies, so it kind of covers most prominent questions or most prominent issues that we generally get when we get into customer engagement for doing any kind of architecture work. So here's a customer who has a current production system running. They experience intermittent performance issues. They have some stability issues with FTS server, where FTS server crashes once in a while, generally like a week, 10-day period. They also see uneven CPU distribution on the backend server. And what this customer is trying to do is they are upgrading their application and platform to the latest version. They also are using Smart IT, but not to the full potential, and they, in the process, also want to move the users from mid-tier to start using Smart IT and keep mid-tier only for administration type of activities. Today, they have varying hardware, meaning some of their servers are 4 CPU, 16 gig, the other servers are 8 CPU, 32 gig. And so in the process, they want to standardize the hardware with a standard configuration. Also, they have too many servers today. So in production alone, they have close to, one of the customers, for example, had 40 VMs. And that does not include dev and QA. So if you add development, the hardware for development, for QA, and then for production, they end up with enormous number of VMs, enormous number of servers. And so The challenge is whenever they want to upgrade, they need to go through this whole cycle. Even applying OS patches requires upgrading so many different servers. So they want to consolidate and reduce the hardware in the process, and also address some of the issues that they are observing in production as part. So here's again a simplified diagram for this customer. So in here, they have approximately 12 mid-tiers, 2 RSSO, 2 chat, 2 reporting servers, 2 smart IT servers, and then they have user-facing ERs, 12 in number, and then 4 backend ER server processes. They have Oracle 2 rack node database, and they are using DataGuard to replicate their database for high availability and disaster recovery. So this is the setup, and we'll come back to this diagram again when we'll talk about the solution or the proposed architecture that we came up after doing all the reviews. So the last piece of information that we got on this case study is this is how they have the 4 servers, backend servers, and this is how they have configured the jobs. So they have all the ones that are in yellow as ranked 1. So they have admin, approval, escalation, assignment, all of these ones running on the node 1. The node 2 is acting as a failover node. And then they have a few other activities. So they have normalization, which is heavy in their environment, scheduled on node 4, while they have email running on node 3. So we'll again come back to this case study once we go through all the basics around architecture deployment. So let's start on the Remedy architecture. So 3-tier, web, server, and data tier. We'll zoom into each of these layers, web layer, data layer, and server layer one by one. We'll also cover the backend activities, backend processes, FTS, and smart reporting in detail. So you can actually have a single server, a single web tier hosting your mid-tier virtual chat, RSSO, smart reporting if you are a classic ITSM customer. If you're smart IT, you can deploy smart IT also on the same web server. We do recommend using separate Tomcat. So have separate Tomcat for mid-tier, for virtual chat, for RSSO. Do not put all on single Tomcat, because that would lead you into upgrade challenges, things like that. And then if you are also a DWP advanced shop, so digital workplace advanced, then this is how your architecture could look like if you just go with single servers. So getting to the web tier. So this is the first alternative we saw, where you are pretty much vertically scaling. So you should have this server that's beefy enough. So it should have enough CPU, memory, all the resources to handle all these applications and handle all the user workloads coming for these applications. So this is one extreme. Obviously, there are pros and cons. On one hand, this may result in better utilization of the resources, assuming all components do not have the peak load coming at the same time. Although you should make sure that if the peaks can occur at the same time, then this server is beefy enough to handle it. So why do we horizontally scale? One reason is if you want to isolate a service, for example, or if you want to isolate a workload. So for example, here, what I've shown here is separating the digital workplace advanced and then smart reporting. Okay, Okay, let me continue. So let's say if you have a heavy smart reporting workload in your environment, then it's advisable to separate that out from rest of the components. Otherwise, smart reporting will end up impacting your smart IT, mid-tier, and other components. The same thing with digital workplace. Typically, for any medium or large customers, what I've noticed is they do tend to have a separate DWP environment. So along the same lines, if you separate, if you are separating RSSO, also makes sense because it's a shared service used by smart IT, by mid-tier, by smart reporting. Let's say if you put RSSO here, and because of smart IT, RSSO goes down, then you there's no point in having DWP advanced separate. So again, separating shared service makes sense. So the other extreme could be you horizontally scale and you have separate VMs or separate servers for each of these components. This actually simplifies quite a few things. For example, if you have performance issue, if you see high CPU utilization, it's relatively easy to identify which component is the culprit here. Although now, since you have 7 servers here, if you add high availability to this, you'll end up with 14 servers total. So again, the management would now become more complex. Moving on, Greg, is it okay right now, or?
Yeah, it was good. Towards the end, you cut out again, and so I'm not sure if it was just a natural pause or whatnot. But
I'd like to Hugo or Doug or Jeff. Do you see the same thing? Because I just want to make sure that I'm audible. Can somebody confirm that?
Yeah, I can hear you, but there's long pauses. So I don't know if that's the audio or those are just natural pauses, like Greg said. So the audio's coming through fine.
Okay. Sounds good. Let's continue. So again, that was web tier. Now coming to the server tier. Again, this is the most critical tier as it is responsible for executing all the application logic. So what is the overall objective here? First of all, we needless to say that we should have enough capacity to handle the peak workload. Also, this tier is responsible for online and batch processes. And this is where architecting becomes important. If everything is equally important, if there are no business priority, rather the priorities are equal from business point of view, then yes, you can deploy everything on a single server. However, business tends to prioritize online users compared to batch transactions. Online applications are favored compared to reporting, for example. So in such cases, you can deploy multiple AR servers, a subset dedicated to online user-facing, while the rest of the servers dedicated to batch processes. All of these servers pertain to a single server group. You can then horizontally scale within this subset as required by the workload. Further, you can dedicate AR servers, even within the user-facing, you can dedicate AR servers to specific workloads. So in here, you can dedicate a set of servers, AR servers to smart IT, the other set of servers to smart reporting. The benefit is that now you can actually fine-tune this server to handle the smart IT workload. Again, the second set of servers you can fine-tune to handle smart reporting workloads. You can have different garbage collection policies here compared to the user-facing servers. One parameter that is important is max entries per query. By default, it's set to 2,000, which is good for online application like Smart IT. But for smart reporting, you can consider bumping it up. So, for example, if you have a report or if you have many reports bringing, say, 50,000 records, if you keep it to max entries to 2K, then you'll end up firing the SQL query about 25 times, going to the database to bring those 50K records in 2K chunks. Compared to that, if you change it to say 25K or 50K, then you will be firing that query only once or twice. Again, whatever setting you come up with, make sure that you validate by running a loop test. So on the back end, the batch processes can be configured via ranking and service failover form. The objective is to make sure that the load is balanced. Also, in case of server fail, in case a server fails, then the server with the next higher rank takes over that operation. So how do you plan? Like, what is the first decision? The first decision is to decide whether you want to just limit running the batch processes on this backend server, or do you also want to expose online servers or user-facing servers for this type of activity? If you decide not to impact online users, then make sure that you are not configuring any of the online servers in the ranking form, and you are limiting the backend servers only to handle all these batch processes. Depending on the criticality, you may want to rank a service on more than 2 backend servers, so that if both goes down, then there's still one more to handle the load. Another important point here is make sure that the server has enough capacity to handle the processes that they are running, and also the processes that are configured so that, let's say in this case, if server 1 fails, server 2 should have enough capacity not just to run email and AI, but also administration, approval, escalation, assignment, FTS if both 1 and 3 goes down. So it should have enough capacity to handle all of these various processes. Coming to FTS, so the default configuration really is where you have FTS ranked as primary on server 3, and then ranked as 2 on server 2. So as 1 on number 3 and as 2 on number 2. This is primarily used for searching. Both of these FTS are doing indexing. If this fails, then obviously this becomes the primary and all the searching load goes to the server. So that's the default configuration. Now for customers who are using Smart IT heavily depends on FTS. So Smart IT heavily uses FTS. And so in this case, these are a couple of alternative models. So the very first model is, rather than just having rank 1 do the searching, you can manually point your user-facing server. So in this case, we have 4 user-facing servers. What I've done is I've pointed 1 and 2 to the backend server with FTS rank 1, and then the other ones to the second server. In this case, even the searching load is being handled. For whatever reason, if server 1 goes down, then all the searches will go to the second server. But rather than just having server 2 sit there for high availability purposes, it is actually being utilized for searching. And there's a knowledge article. I've put that in the note. We did some exhaustive testing So I would say go through that knowledge article. It has the pros and cons for these alternative deployments. The other option or the other alternative is to put a load balancer and just have the load balancer distribute the searches across the two FTS servers. Obviously, the benefit, so here it's quite possible that the load may be imbalanced between these two, depending on if there are less searches happening on these two servers or not. Here, the load with the second option would be relatively more balanced. So again, those are some pros and cons to consider. All in all, this actually is a good alternative than the default one. Again, as I said, for users coming from Smart IP, because in our testing, what we saw is that this provides. So if you just have a single search and during heavy load, we had the searches taking like 5 seconds, versus this came down to under a second when we actually distributed the load. So it performs better, it scales better. Okay, moving on. So we talked about the web tier, we talked about the server tier, and now we are on to the database tier. So Remedy application is database agnostic. You can follow the best practices provided by the vendors, so Oracle or Microsoft for Oracle and SQL Server database. There are specific settings applicable to the Remedy application. Again, these are all documented in the knowledge article, I mean, I have the articles documented in the reference slide in this presentation. So for this presentation, I'll primarily focus on Oracle and SQL Server, as most of our customers are on these two databases. So here's an example of single server, single database. That's your typical deployment. Moving from that point, their customers do tend to have some redundancy at the IO subsystem level, be it some IO subsystem configuration or a RAID configuration. For example, RAID 0+1 provides redundancy and better performance for read and write both. So that's something that we recommend. Any RAID 0+1 or equivalent configuration, it's a preferred configuration. And then for Oracle, you can also have redundancy at the node level, so that you have two nodes in the rack type of an environment, so real application cluster. These two nodes can be active-active, and so that provides you redundancy at the node level as well as at the database level. So here's a typical Oracle configuration that we see being used by most of our medium or large customers. You can have two or more rack node clusters with your site being on the primary site. And then they typically use data guard to do the replication. So this is where you have additional two rack nodes, and this is your standby database. So if, for example, if this site goes down, then you would end up failing over to the DR site. In your normal production operation, this site is these nodes are generally in recovery mode, so they are applying the logs coming from the production environment, and then as soon as the failover happens, basically you apply the last log, you activate the database, so you open the database and you start using it for the production. On the SQL Server, there's a concept of always on. So in here, you can again replicate your database using the always on feature. What we recommend is using, so you can use it either either synchronous mode or asynchronous mode. What we recommend, and this is something that we use in our on-demand offering as well, where we have asynchronous mode set, so that you are not impacting or you are not holding up the primary environment. So there's no performance impact if you are using asynchronous mode with the always on option. So that's the SQL Server database. So coming to smart reporting. So in the smart reporting, you have, so this is where, again, extending the conversation where we separated the AR servers for smart IT versus smart reporting. So for smart IT, you could actually then point to the read-only database. So your secondary database or your standby database, you can leverage this hardware by pointing the smart reporting AR servers to this read-only database. The benefit is obvious. One is you are offloading all the long-running SQL from the primary database to the standby database. Typically what we see is if you have smart IT and smart reporting all running on the same server, again, for some customers, the smart reporting workload is heavy. If you look at the EWR report or if you look at the top SQL statements, 7 out of 10 would be pertaining to smart reporting workload. So in order to make sure that your smart reporting workload is not impacting your online users, what you can do is you can separate the AR servers and then you can point it to the read-only database. Now there is a price for this. While the benefit is obviously now you have isolated the online user, also you are leveraging this hardware not just for disaster recovery, but you are using it for read-only purposes. The issue is both Oracle and SQL and Microsoft requires licensing. So you need to have licensing to use this even for a read-only type of workload. So let's say if you have that type of limitation, and we did have a couple of customers who had licensing limitation. In that case, what you can also do is, although the preferred approach would be to just separate it on a separate database on the secondary database, the other alternative could be that you use different users for smart IT and smart reporting so that you can differentiate these users coming at the database layer. And once you can differentiate, then you can actually use resource control to make sure that you are limiting the CPU and memory utilization for smart reporting users versus smart IT users. This basically, again, is to ensure that you don't have some user firing a runaway report, thereby impacting the smart IT users coming to at the database layer. So I guess that's pretty much what I had on the design discussion. So let's move to the case study. So before we get into the looking at what we did, one thing we realized. So this is the original diagram we had, and again, this is the problem statement we got. In here, the very first thing we realized is that while we got the information, and then by the way, we collected a lot of additional information as to what are the configuration, what is the workload. Once we got all that, along with all the how the backend processes are scheduled, what we realized is that we also needed, because we wanted to consolidate the hardware and standardize the hardware, we also wanted to know how is the current production system running, what is the current utilization, what is the current capacity that is being used, and what is the available capacity. By the way, for any capacity planning, generally, again, we consider physical cores and then not logical, while and then also we consider 70% of the CPU utilization, so no more than 70% average. If you, I mean, even at 70, you'll see a lot of peaks of 100. So beyond 70, again, it may start impacting the response time. So let me go to the slide where we came up with the alternative model that we proposed. And by the way, as I said, there's no one design that fits all. This is one of the proposals we made and we went with. Again, there were multiple steps in between. I'm kind of jumping to the final solution here. So the very first thing we did was we reduced the number of mid-tiers to 5. So from 12, we came down to 5 because mid-tier, what we realized is that the capacity was really over-allocated at the web tier. So 5 mid-tier servers also hosting Smart IT on separate Tomcats. So that was, again, the deployment architecture we went with. We separated smart reporting because we also wanted to make sure that all the online users had consistent performance. So smart reporting is now pointing to 2 separate AR servers and pointing to the secondary database. What we did not do is reduce any capacity at the AR layer because we realized that AR servers were utilized at 40–50%. And since the customer was expecting more workloads, it was better to leave that additional capacity there. And then on the back end, rather than just using the FPS default configuration, we load balance it to use multiple clusters. So this is how we reduce quite a few servers at the mid-tier layer, and then also separated Smart IT and Smart Reporting traffic. And also used FTS for in a load balanced fashion. So on the backend server, as you can see, the second server was primarily used for just failover. So in here we actually started distributing that load as well, while making sure that each one has capacity to handle all the processes configured on that particular server. So we moved escalation, AI, and archiving on this. We also moved email. We separated email. So this customer had heavy traffic on the email server. So we separated the email incoming and outgoing box, and then moved email outgoing on the second server. And then both these FPS were actually leveraged for searching, and obviously they do their own indexing as well. So all in all, the end result was we made sure that the complete environment had enough capacity at each tier. We standardized the hardware. We also reduced the total footprint, especially on the mid-tier. And by the way, mid-tier was not just reducing the number of servers. It required making sure that the EH cache had right parameters, the JVM was tuned, the Tomcat had right settings for max thread, accept count, things like that. So there was a lot of in-depth work done to come up with the new architecture. So I think that concludes. Hopefully that you find this useful. So moving on to performance validation. Again, this, as I mentioned, a lot of times this step is either missed or is not emphasized enough. And I cannot emphasize how important it is to validate any change via load test. I mean, we have examples after examples when we work with customers. There's a customer who decides to move from one data center to another. They do everything right in terms of planning, designing their architecture, making sure to follow all the best practices. But the only step they miss is they don't do any load testing, and obviously they encounter all the issues on day one, and then there are escalations after escalations. There is another example of a customer who did the testing, but they missed a couple of critical parts. So while they did the testing, their workload was not representative enough to simulate day in a life type of a scenario. And so while most of the things worked fine, there was a critical piece where they saw a performance issue. By the way, I know of a big bank who have a team of performance testing team who does exhaustive testing for any change that goes into their production, and for most part they are pretty successful in their go live. There's another customer that we worked with late last year where they had a tool that they wanted to obsolete and move users to Remedy. And so pretty much Remedy would now have double the workload. And they were also upgrading to one of the later versions. And we worked with them to do exhaustive testing. And they had one of the smoothest go live in their history of upgrades and in their history of rollout, primarily because we did the right testing. We identified that there was additional capacity required at the server tier. And so again, that is an example of a successful performance validation coming from a customer. So coming to this slide, basically a few tips that I would give. One is start small. Make sure you start small and then work your way up to creating a day in a life type of a workload for testing. A lot of time, what I've seen is customers make mistake of starting with a very complex scenario, and then they don't have a good baseline. They don't have a good way of figuring out where to go next. So again, keep that in mind. The other thing is, I mean, some of the common techniques, right? So end user response time, that's one of the easiest way to look at the performance. So if your end user response times are bad, then really there's no point in running a load test. We need to fix that and then get to the load testing. Your load testing would actually be worse if your single user response times are not good. Again, depending on the objective, you could be doing performance/load test, or if you want to make sure that your system is reliable, stable, then you could be doing an endurance test. And then if you have other requirements, for example, one of the customer had requirement where they anticipated 400 to 500 users logging in pretty much around the same time at 9 a.m. in the morning. And so they wanted to make sure that they do a stress testing just of logging in, logging out to identify any system limit or identify any tuning that they need to do. Some of the tools that are mentioned here are primarily used for load testing. So Fiddler and HTTP Watch is single user tools that generally to measure the traffic between client and the web tier. You also have Self Performer, Scapa, Load Runner, and JMeter. JMeter is an open source tool, so that's again now being used by more and more customers. We have also started using that in our lab along with Self Performer. And I mean, if you have smart IT, you can pretty much use any of these tools: JMeter, Self Performer, Scapa, Load Runner. If you're mid-tier, then I know that Self Performer works quite well because it simplifies the automation. So if you have not already read the benchmarking best practices guide for Remedy applications, please do so. It describes the approach to the successful load testing, covering end-to-end spectrum from planning, designing, execution, analysis, and reporting. So I won't go into the details of that, but what I wanted to do is discuss a few common mistakes that typically customers make. So the very first one is we actually recently worked with a service provider who was expecting to onboard a large customer, and their load test was failing with really bad response times. And when I say really bad, meaning these response times were most of them were in 2 digits. ranging from 11 seconds to 18, 19 seconds. And so when we started working with them, what we realized is they did not really have any think time or transaction pacing in their automation, which means that the users will log in, will go through the steps one by one, one after another, again go to the next transaction as soon as they complete the first one. So the very first question I asked them is, what exactly is the expected tickets that this customer that's coming up would have? And in their case, it turned out they wanted to simulate 40,000 tickets per day. Now, considering 8 hours working day, the average ticket per hour comes to about 500 tickets. So that's average. Now, again, I should caution that don't just depend on the average, because average could be quite misleading. What we need to focus for any kind of performance validation is peak workload. If you take care of the peak, the rest of the duration will automatically be taken care of. So with 500 average per hour, even if you took say 1,000 or 1,200 tickets per hour as peak load, what we did was we then introduced transaction pacing and think time to simulate a real life user. These users will all come in and will be creating 1,200 tickets per hour. Once we did that, we started seeing normal response time range in 3-second range. And again, that was the end of that escalation. What customer was actually doing is they were running the load that was 5 times heavier. If you really want to, if that is the objective, then you need to, again, size your system accordingly. But for the system that was configured, that was just way too heavy on their environment. Another common mistake is the automation scripts itself should be reflective of a typical workload. So, for example, if you are simulating a backend support user, this user should not really be logging in and logging out with every transaction. If you think of a typical support user, he'll come in the morning, work through the day, create tickets, update, do some searches, and then maybe log out once or twice during the daytime. However, if you are simulating an end user in digital workplace, for example, then a typical user will come in, log a request for some issue with their laptop, and then log out. That should have login and log out. If you're not doing that, then you are not really simulating the actual workload. So again, make sure that your workload is realistic, workload is representative, and it is translated accurately in your automation as well. If you have users like support users, then they should actually be leveraging caching, because that's going to be their normal day-to-day scenario. Finally, in general, the approach should be, as I mentioned, start small, start with a clean, good baseline, and then work your way to add more complexity to make it more realistic. A lot of time customers start with breaking point, and this is something I've heard, like why should we test normal workload? We want to stress the system, we want to really figure out what the breaking point is. And so they run the test, which is, we term it as breaking point test, and then the system breaks, and then they're surprised that why did the system break? So again, there should be a methodology to start simple. Make sure that you have good baseline, and then you start adding. That would actually also help you. Let's say if there's a performance issue, then that would help you in isolating that issue, because now you know what changed in the system, and you have a controlled environment to work with. So ensure that you follow the right methodology. Again, as I mentioned, if you have not gone through the performance benchmarking best practices, please do so. Finally, on monitoring and tuning, I mean, there are dedicated presentations that are coming up on JVM monitoring. There's one on database performance. What I want to emphasize here is, I mean, generally customers have implemented some kind of monitoring, either using a commercial tool or using operating system utility. Although the important point here is how you use that data. So what you don't want is a DBA sitting in one corner looking at the database report. You have system administrator in another building looking at OS level monitoring. And then you have application folks looking at the JVM monitoring, or application admin looking at JVM monitoring. What you really want is somebody to have that performance, to wear that performance hat, who looks at all the data in its entirety. So if you take, for example, 9 to 11 as your peak load, you want to know that during that peak 2 hours, how did the OS look? So how does my CPU look? How does my memory look? How does the I/O look on the database server? The same thing with the JVM monitoring. How does that look as the workload ramps up, touches peak, and then comes back? Is the JVM spending more time entertaining user requests, or whether it's doing a lot of garbage collection, for example? If it's doing a lot of garbage collection, then you want to fix that part. So here's an example. I mean, again, these charts are not all correlated, but just sample snapshots. So let's say if you're doing performance validation, here's the top left-hand corner chart depicting that, where you have users ramping up, and then we reach a steady state wherein they are running all the transactions, and at the tail end they ramp down. And so how does that reflect in terms of system resource utilization, in terms of CPU utilization, in terms of memory utilization? And then the same thing on the JVM monitoring, on the JVM snapshots. So here are a couple of snapshots from 2 different AR servers coming from JVisual VM. That's a utility that comes with Java, so you can leverage that. So in here, this is actually a chart from a real benchmarking that we did, where we saw that one AR server is heavily used while the other one was not used as much. And finally, we identified a bug with the FTS rule that we had put in place. So once we fixed that, then we saw equal distribution. Looking at, again, the top SQL statements at the database layer, top wait events at the database layer, again, that's very, very important. So if you have the top wait event as CPU, for example, in Oracle, and you can look at the EWR report, then you know that your system is spending time on CPU, and that typically is a normal case. Compared to that, if you see a lot of, say, DB files scattered reads, that means that the system is doing a lot of full table scans. And so, again, that needs to be further looked at. Finally, on monitoring and optimization, so obviously you'd be using this for identifying the health of your, gauging the health of your system, identifying any performance issue proactively, and then also making sure that if you see anything, then you fix it. You can also use this data. You can actually build this data to see how your system is behaving with different workloads coming in during different time of the day, during different days of the week. And in the process, you kind of get a good sense of what the current capacity utilization is during the peak load, during non-peak load. That helps you even with some of the planning For example, do we want to move some of the batch processes during off-peak hour? Do we want to schedule the reports rather than having users come in and run ad hoc report during peak load? Should we schedule the reports and put it and then move it during off-peak hours? Things like that. And then obviously for capacity planning. So let's say if you are expecting more additional workload, if there's some site coming that's going to come online in 6 months' time, then you know whether you want to order hardware or whether the current system will suffice. Again, deployment architecture, monitoring, and performance tuning, all of this go hand in hand. If your system is not properly tuned, you may end up with incorrect capacity planning results. A simple example here would be, let's say your database is running at 40% and you think that you are going to double the workload and you don't want it to go over 70%, and so you want to add more CPU in here. But if you look at the top 8 events, it's actually your full table scans. It's not really using, I mean, though it shows 40%, it's not really using, CPU is not the main bottleneck. So even if you add CPU, there's no guarantee that you'll be able to scale this database server. So you need to make sure that the system is tuned, it's reflective of the workload that it is serving, and that should actually give you a good insight into what is required in terms of capacity planning, sizing, all those things. So here's a few important articles that I've put. So configuration checklist, this is something that my team publishes. This has all the hardware sizing. It has all the best practice configurations. Make sure to go through that. If you are interested in technical details, you can actually look at the performance tuning guide, because that explains a lot of the settings that we have documented on the first link here. Performance benchmarking best practices, another good document to go through. JVM monitoring, and then FTS deployment and configuration best practices. So in summary, I would like to emphasize a few points. One is, again, if you are looking for single design, then that's not really the purpose of my presentation. No one design fits every customer requirement. Make sure to articulate your requirements properly, and then apply any recommended best practice, tune it, and tailor it to your environment. So if the best practices, the sizing guidelines are starting point, make sure to fine tune it to your environment. Load test whatever architecture you have designed. Load testing is immensely helpful for other things as well. Let's say you are going to now change the Java version, or you are going to upgrade your database, or you are going to upgrade your application, you are upgrading your hardware. You can actually do a before and after test and make sure that you don't see any issue, or you catch issues before going live in production. Monitor and tune it. As you know, performance management is an ongoing activity. It's not one snapshot that you do it and sit back. It's an ongoing activity. So conduct periodic health checks to make sure that your system is behaving normal and you have enough capacity to handle the workload that you have. I think that's all I had. So I think we can move to Q&A. Greg, did you want to?
Yes, thank you, Vipul. And Lynette, would you be able to tell our callers how they could signal for questions, please?
Yes, sir. If you would like to ask a question, please signal by pressing *1 on your telephone keypad. If you're joining us today using a speakerphone, please make sure your mute function is turned off to allow your signal to reach our equipment. A voice prompt on your phone line will indicate when your line is open. Again, that is the star key followed by the digit 1 at this time. We'll pause for a moment.
While we wait for questions, Vipul, I have a few that came in on chat. First one I have is there a preference between physical and virtual hardware?
Great question. So there is no preference. I mean, different shops have different deployments. Obviously, there are benefits to virtualization. It makes a lot of administrative type of activities very simple. As far as Remedy deployment is concerned, we have, I mean, it's very common to virtualize your mid-tier, your smart IT server, your smart reporting server. You can go with the physical server as well. Virtualization does add one layer on top of your physical server, although, I mean, as long as you have made sure that you have allocated enough resources, as long as you are following the best practices, you're not oversubscribing, for example, in your production environment, virtualization is fine. And you can do it for web tier, you can do it for AR tier, and now, I mean, there were some limitations earlier on with the number of CPUs, and even there were some, I mean, there's a lot of optimization that has happened on how virtualization optimizes the CPU cycle, and also even databases are, I mean, there are a lot of customers who virtualizes the database as well. So either one works fine.
Thank you, Vipul. And Lynette, do we have any questions in queue at this time?
At this time, there are no callers in the queue. However, we would like to give everyone an opportunity to signal. Again, that is the star key followed by the digit 1 at this time.
Thank you. Vipul, I have one more for you on the same lines of virtualization. Can the DB be virtualized?
Yeah, so again, I mean, the database can be virtualized. Generally, I mean, we have seen small and medium shops virtualizing their database. Even in our testing, we have virtualized database and use that. The important point here is, so a couple of things, right? One is the sizing of the database server. That's supremely important unless you are using Oracle RAC, because with Oracle RAC, you have the option of horizontally scaling with if not Oracle, then yeah, I mean, you would have a single server, and then you would have high availability option. But I mean, your single server would be the one serving the load. So you can virtualize it, or you can use physical. Just make sure that it has enough capacity, and you have basically performance tested for the load that you anticipate.
Okay, thank you. And I'll just check back with you, Lynette, on any questions in queue.
There are no callers in the queue.
Okay, I'll continue to my next question I have here is, what is the benefit of ranking multiple FTS servers in the default configuration if only one is being used for searching?
Yeah, so I mean, in the default configuration, the FTS with rank 1 will do all the searching, would handle all the searching load, and then the one with rank 2, or you can have multiple of those rank 2, rank 3, they will be just there for high availability purpose. So let's say if the one with rank 1 goes down, then the second one that's rank 2 would take over the searching load. So it's in the default configuration, it's primarily for high availability purpose. It's not really load balancing your searches, or it's not distributing that load. And that's where we had a couple of alternatives where we suggested that you can either manually point the user-facing AR servers to multiple FTS so that you can leverage both FTS servers for searching, or you can use a load balancer to, again, distribute the load across multiple FTS servers.
Okay, thank you. And just a quick check back, Lynette, anybody queued up for questions?
And there are no callers in the queue.
Okay, if you want to give directions one more time to ensure everybody is clear.
And again, that is the star key followed by the digit 1 if you have a question or a comment.
Vipul, I have one last that I have to ask here, and it's what if the production environment, the sizing of the production environment, there's too many users, it's oversubscribed. What are the options at that point, or how is that addressed?
Yeah, so again, I think as I mentioned, generally it's, that's the whole benefit of virtualization, right? You can oversubscribe, and let me quickly define what that means. So let's say if you have a ESX server with 16 CPU, 64 gig RAM, and you want to deploy VMs, each VM should have 4 vCPU, then in that case, what not oversubscribing means is that you should not be deploying more than 4 VMs. So you're not going beyond the 16 CPU that you have. And again, when I say 16 CPU, we consider physical cores and not logical. For development and QA, it's okay to oversubscribe, meaning if you have 16 cores and you want 10 VMs with 4 cores each, that's fine because performance is not really the focus there. However, for production, you want to make sure that when your peak load comes in, if your system is sized properly, then you want the CPU to be available, you want the memory to be available. So in that sense, make sure that you are not oversubscribing. Now, if you have multiple components and you know for sure that each of these components will not have the peak load at the same time or cannot hit the peak load at the same time, then yes, you can oversubscribe. But generally the rule is make sure that you have enough capacity when you think of creating the VMs or when you are virtualizing the hardware.
Thank you for clarifying that. Lynette, and I would back with you.
And there are no callers in the queue.
Okay. Vipul, you wanted to add another comment on that last question?
Yeah, I just wanted to add one more thing, like the configuration checklist, the very first link that I had in the presentation, that actually provides the sizing guidelines as well. A few questions that I've gotten is, what we'd say is that you can have so many servers with so many CPU and memory. And so one of the questions I generally get is, the CPUs could be different, right? The OSs are different. How can we generalize this? And so while I agree that this is oversimplified, typical approach is this, right? What you need to do as customer is look at the general guidelines, and at the same time, we actually publish our benchmark reports where we document exactly each and every component, each and every hardware, make, model. So you get exactly what kind of hardware we use and how many users we ran, things like that. So the combination of the checklist and along with the benchmark report should give you a good picture as to the hardware being used by us and the hardware that we recommend. So again, shops are different. Some may have Solaris, Oracle, some may have Linux, Oracle, others could be Windows, SQL Server. So make sure that you translate that into as per your environment, and then again, the most important point is make sure that you load test whatever you have.
Okay, thank you for that addition. One last call, Lynette. I'm just checking if there's any questions that have been queued up.
There are no callers in the queue.
Okay. At this time, without any further questions, we'll go into our wrap-up now. Wanted to just cover the self-help and contacting BMC. We do have a YouTube channel for the BMC Remedy and Discovery. This is where this recording is published, along with our previous webinars, as well as a rich set of how-to videos that you can see on that YouTube channel. Our webinar schedule is in communities, available at this doc link, and also via our product support pages. These have links for each of the products to the different areas of documentation, knowledge, related videos. You can look at on the product support pages and the normal channels for contacting technical support via web, phone, and email, as well as via the social channels. Again, I wanted to thank everyone for joining today, and this recording along with the Q&A will be posted within a week of today's live showing. And that concludes this session this month. Thank you to everybody that joined and all of our presenters and panelists. Thank you.
That does conclude today's teleconference. We thank you all for your participation.